Welcome. In this session, we'll be conducting a detailed analysis of a significant piece of technical source material focused on cloud computing architecture and career paths. The book is The Self-Taught Cloud Computing Engineer, covering AWS, GCP, and Azure. It's important for you, our technical audience, to know that this analysis has been professionally generated using an artificial intelligence platform. This ensures we cover the material comprehensively and clearly.
Our goal today is quite focused. We aim to extract the essential architectural insights and career advice from this guide. We won't just be listing features. Instead, we'll perform a detailed comparative analysis. Think core differences, operational considerations, the nuances in compute, data, and security across AWS, GCP, and Azure. We want you to leave with insights you can apply professionally.
Okay, let's begin with the AWS section, specifically starting with compute, as laid out in Chapter 1. The source traces the evolution, from early physical machines like ENI right up to the virtual machine concept. This leads us to Amazon EC2 instances, which are framed as disposable resources in modern infrastructure.
That's a fundamental concept, and the evolution continues within AWS itself. We see a progression. First, EC2, the standard virtual machine. Then comes the container layer, managed perhaps by ECS or EKS. And finally, serverless, represented by Lambda. Now, the critical point about Lambda from Chapter 1 is its resource allocation and pricing. Resources are dynamic. You pay strictly for usage, for the execution time, not for idle capacity.
That's a major shift from managing VMs. Now, moving to storage, Chapter 2 differentiates three primary types. First, Elastic Block Store, EBS. That's block storage attached directly to an EC2 instance. Then you have Elastic File System, EFS, which offers elastic shared file storage accessible by multiple instances.
And the third is the Simple Storage Service, S3. This is the cornerstone object storage. Chapter 2 reminds us of a crucial operational detail. S3 uses a global endpoint, meaning bucket names must be unique worldwide. While S3 storage itself is vast, individual objects have a size limit from 0 terabytes up to 5 terabytes. For moving extremely large datasets, the source also mentions the Snow family services. Think Snowball, and even Snowmobile, which has a massive 100 petabyte capacity per truck.
Okay, let's synthesize networking concepts from Chapter 3. The virtual private cloud, or VPC, in AWS is regional by design. Access to the internet typically involves an internet gateway, IGW, and perhaps network address translation, NAT, for private instances needing outbound access. But a common point of technical confusion highlighted in the source is the difference between the two main firewall types.
Understanding this difference is absolutely essential for proper security architecture. Security groups, or SGs, are stateful. They operate at the instance level. Stateful means return traffic for allowed outbound connections is automatically permitted. Network access control lists, NACLs, are different. They are stateless and operate at the subnet level. Stateless means you need explicit rules for both inbound and outbound traffic. Critically, NACL rules are evaluated in numerical order, and the first matching rule applies. A deny rule early on can block traffic even if a later rule would allow it. That sequence is vital.
Let's turn to AWS data services covered in Chapters 4 and 5. The source details the core database offerings. There's the Relational Database Service, RDS, supporting common database engines, often with multi-AZ setups for high availability. And for NoSQL, there's DynamoDB, the key value store. Operationally, scaling it involves managing read and write capacity units, RCUs, and WCUs.
Chapter 4 also mentions Elasticache for in-memory caching needs, speeding up data retrieval. And then there's Redshift, a data warehouse using columnar storage, which is highly optimized for analytical queries, what we call OLAP workloads. Chapter 5 moves into the big data pipeline components. AWS Glue is presented for ETL tasks and managing the data catalog. Amazon Athena is highlighted as a serverless service for querying data directly in S3 using standard SQL. Very powerful. And the Kinesis family data streams, Firehose Analytics, forms the backbone for handling real-time, high-volume data streams.
Chapter 6 and 7 address machine learning and security. For ML, Amazon SageMaker is positioned as the comprehensive platform. It covers the end-to-end lifecycle, building, training, deploying custom models. AWS also offers pre-trained AI services like recognition for image and video analysis and comprehend for natural language processing tasks.
Security, detailed in Chapter 7, fundamentally rests on the shared responsibility model. You need to understand where AWS responsibility ends and yours begins. Identity and access management, IAM. It's central, using role-based access control, RBAC, and enforcing multi-factor authentication, MFA. The source gives a good technical example of an automated security setup. GuardDuty detects a threat, triggers a CloudWatch event, which then invokes a Lambda function for automatic remediation. That automation is key in modern cloud security.
Okay, let's transition now to Google Cloud Platform, GCP, covered from Chapter 8 onwards. GCP presents some different architectural philosophies. The resource hierarchy is logical: organization, then folders, then projects, and finally resources within projects. But a major difference, as Chapter 8 points out, is in networking.
Absolutely. The standout architectural feature is GCP's Global Virtual Private Cloud, the VPC. Unlike AWS, where VPCs are regional constructs, a single GCP VPC can contain subnets located in different regions around the world. This inherently simplifies global network designs. Core compute includes Google Compute Engine, GCE, their VMs. For containers, there's Google Kubernetes Engine, GKE, and object storage is Google Cloud Storage, GCS.
Chapter 9 delves into GCP's data services, which includes some quite specialized offerings. Cloud SQL provides managed relational databases, similar in concept to RDS, but Cloud Spanner is unique. It's described as a globally distributed yet strongly consistent relational database. It's designed for huge datasets needing low latency access worldwide. Achieving both global distribution and strong consistency is a significant technical challenge Google addresses here.
For NoSQL, Chapter 9 discusses Cloud Firestore. It's a document database offering real-time synchronization capabilities, making it popular for web and mobile apps. And BigQuery is GCP's flagship data warehouse. It's serverless and built for petabyte-scale analytics. The typical GCP big data pipeline is often described as Cloud PubSub for message ingestion, Cloud Dataflow for processing, stream or batch, feeding into BigQuery for analysis. Quite streamlined.
GCP is also very strong in the AI and machine learning space, which Chapter 10 covers. Vertex AI is presented as their unified platform for the entire ML workflow. It integrates various tools like a feature store, AI workbench for development, and AutoML capabilities to simplify model creation.
Beyond custom models, GCP offers powerful pre-trained models through its ML APIs. Chapter 10 mentions the Site API, covering vision and video intelligence, and the Conversational API, which includes services like Dialogflow for chatbots, text-to-speech, and speech-to-text. For security, Chapter 11 reviews GCP's IAM structure: primitive roles, more granular predefined roles, and custom roles. Service accounts are crucial for application and service identity. The Central Security Dashboard is the Google Cloud Security Command Center, SCC. It provides asset discovery, vulnerability scanning via Security Health Analytics, and integrates with tools like Cloud Data Loss Prevention.
Our final platform in this analysis is Microsoft Azure, starting with Chapter 12. Azure is well known for its strengths in the enterprise sector. Its resource management hierarchy starts with management groups, then subscriptions, resource groups, and finally individual resources. For compute scaling, Azure uses virtual machine scale sets, VMSS.
Azure provides container orchestration with Azure Kubernetes Service, AKS, and also Azure Container Instances, ACI, for simpler container deployments. Their serverless compute offering is Azure Functions. In networking, Chapter 12 also introduces the Azure Virtual WAN, or vWAN. This uses a hub-and-spoke model to provide global connectivity and centralized network management, often appealing to large organizations.
Now, focusing on Azure's data services in Chapter 13, the core storage building block is the Azure Storage Account. A single storage account can host different data types: blobs, object storage, files, shared file access, queues, messaging, and tables, NoSQL key attribute store. A key evolution for big data is Azure Data Lake Storage Gen 2. It builds on blob storage but adds a hierarchical namespace, which is crucial for optimizing performance in large-scale analytics.
Azure Synapse Analytics, formerly SQL Data Warehouse, is positioned as the unified analytics platform in Chapter 13. It brings together traditional SQL-based data warehousing using Synapse SQL pools or serverless on-demand queries with big data processing capabilities using Apache Spark and integration with Databricks. Moving to AI in Chapter 14, Azure Machine Learning provides the workspace for developing custom models. Azure also heavily promotes its pre-built AI through Azure Cognitive Services. And a significant offering is the Azure OpenAI service, providing managed access to powerful large language models like GPT-3, Codex for code generation, and DLLE for image generation.
Chapter 15 covers Azure Security. Identity management centers on Azure Active Directory, integrated with role-based access control, RBAC, and privileged identity management, PIM, for controlling elevated access. Network security often relies on network security groups, NSGs, which function similarly to AWS security groups.
For security monitoring and response across the enterprise, Azure Sentinel is the key service. It functions as a cloud-native SIEM, security information and event management, and SO, security orchestration, automation, and response solution. Chapter 15 also emphasizes governance through Azure policy, citing an example like enforcing a policy that network interfaces should not have public IP addresses assigned, applied at a high level like the root management group. This really reflects that enterprise focus on central control.
That brings our detailed architectural review across AWS, GCP, and Azure to a close. The final chapters, 16 and 17, shift focus to something equally important for you: career development in the cloud space. Chapter 16 outlines the certification paths for all three providers, generally foundation, then associate, and up to professional, expert, or specialty levels. The source addresses that preparing for these is a systematic process. Study the material, do hands-on labs, and take practice exams.
Yes, but Chapter 17 makes a crucial point. Technical certifications are just one part of the picture. The cloud job market is growing rapidly, but success requires more than just technical knowledge. To advance, particularly into architect or senior roles, the source highlights the need for strong, soft skills.
Can you elaborate on those soft skills mentioned in the book?
Certainly. Chapter 17 emphasizes clear communication, being able to explain complex technical ideas to different audiences, including non-technical ones. Collaboration and teamwork are essential, as cloud projects are rarely solo efforts. Persistent problem-solving skills are a must. You will encounter unexpected issues. And professional conduct, things like upholding ethical standards and respecting data privacy, are non-negotiable. Finally, the author shares key advice. Always maintain gratitude and, very importantly, commit to lifelong learning. The cloud landscape changes constantly.
This analysis has covered a vast amount of technical detail, comparing the architectural approaches of AWS, GCP, and Azure based on the comprehensive guide, The Self-Taught Cloud Computing Engineer. We've aimed to highlight the key operational differences and nuances critical for cloud professionals today.
Indeed. For anyone listening who is serious about truly mastering these platforms, understanding the trade-offs, and getting the necessary hands-on experience, we professionally recommend reading the book in its entirety and completing the labs provided. This knowledge is foundational.
As you continue learning and building in the cloud, here's a thought to consider: extending from the source material. We see serverless, like Lambda, as an advanced stage of consumption-based computing today. What might be the next major architectural paradigm shift, perhaps driven by advancements in areas like quantum computing or new cryptographic techniques that could reshape cloud engineering fundamentally? That's the kind of future evolution to keep an eye on.
We hope this analysis was valuable. We encourage you to subscribe for more sessions exploring technical topics in depth.
Thank you for joining us. We wish you a great day.